I'm sorry, I can't make this full screen. It is what it is. Your polynomial function is basically I'll give you an example, function like x cubed minus 6x squared plus 10x minus 8. Okay? The first thing you need to look at is what's called the degree of the polynomial and the leading coefficient. And hopefully you will be familiar with both of these. What's the degree of this polynomial that I just did up here?
4.
3. Why 3? It's the highest degree. It's the highest exponent of your variable, okay? So your degree is the highest exponent of the variable. So we have a degree 3 polynomial up here. Very important to know, because we know what degree 3 polynomials look like, and that actually helps us. The leading coefficient is the other thing you need to look at, because depending on if it's positive or negative tells us where our graph starts and where it ends. So what would be the leading coefficient then? What do you think it would be?
1.
1. It's the number, the coefficient of that highest degree. That would be your leading coefficient. Coefficient of the highest degree. Now, just so you know, this can obviously, they can move that degree and that leading coefficient. Like they could put this in the middle here. They could have put negative 6x squared. It's not always going to be in the front. So just know that in a degree, well, just look at your polynomial and make sure that you're picking the highest degree and then picking the number in front as your leading coefficient. So very easy homework problems tonight. You'll have like 3 like that. All right, so now let's talk about zeros, which we've talked about before. Zeros are the value of x for which f of x equals 0. That's what a zero is called. It's the value for which f of x equals 0. The value of x for which f of x equals 0. No. Zeros.
Zero.
Yeah. It's a zeros. This right here, if you remember back to like lesson 1 or 2, I can't even remember, but we talked about where zeros occur. They are your x-intercepts. X-intercepts are your zeros. So please put that in your head and get used to seeing those. So then the second part of your homework will say this. Here's an example. Determine whether 4 is a zero of the polynomial function. I think I chose the same one above. I did. Determine whether 4 is a zero of f of x equals x cubed minus 6x squared plus 10x minus 8. Okay, so 2 ways to do this, depending on if you're allowed or not allowed a calculator. Okay, first of all, what would be the first way that you would figure out if this was a zero? Plug it in and get out a what? 0. Yes. Plug it in. If you plug it in, and you find f cubed minus 6 times 4 squared plus 10 times 4 minus 8. If that becomes 0, then 4 is a zero. That's why it's called a zero. If you're allowed a calculator, though, if this was like a section on a PSAT or SATs, I would suggest you let the calculator do this hard work for you. You actually check in your calculator the table. So hopefully I have this still saved in here. I don't. So in your calculator, you would type x cubed minus 6x squared plus 10x minus 8. Go to the table and go to 4. And I know it's hard to see. Can you see that it looks like a 0? No, it's a little blurry. The calculator will do the plugging in for you. So I checked my table. I went to 4. I got out as 0. Now be careful. A lot of students actually go to 0 here on the X, and that's not what we want. We want 0 to be our Y output. Okay? So yes, 4 is a 0. So I'm trying to show you both ways again, because if you can use a calculator, please let the calculator do all the work for you. If not, then you got to plug it in. All right, so that's that first one. So then there's this word roots. Again, these are all words you've heard in Algebra 2, but what's the difference between them? Let me explain real quick. Zeros are real values, whereas roots are solutions, the solutions of polynomial equations, which can be real or imaginary. So they're kind of the same, except roots can actually have eyes. So if the question said, find the zeros, they're actually asking for the real stuff, the stuff that crosses the x-intercept. But if the question said, find the roots, you have to find even the imaginary ones. And it's not hard to find, and we're going to talk about that momentarily. But let me give you this definition here of what's called the fundamental theorem of algebra. The fundamental theorem of algebra. And I know you're like, but we're in pre-calculus. Yes, but this is actually what you've been striving for your whole algebraic career. The fundamental theorem of algebra says the following, that every polynomial equation, and I'm abbreviating, every polynomial equation with a degree greater than 0 every polynomial equation with a degree greater than 0 has at least one root in the set of complex numbers, meaning real or imaginary. That's what complex number system, if you don't remember that, that's what it means. Just every single polynomial equation, as long as it has a degree greater than 0, so x to the 1, x to the 2, x to the 3, has at least one root. That root can either be imaginary or that root can be real. Okay, it's got to have one if it has a degree greater than 0. So let me visually get this in your head. So I'm gonna give you some graphs right now. And we're going to talk about them, and then we're actually going to do 2 problems, and we're done. I told you, this isn't a terrible... Now, it's crossing the x-axis at one point. Do you all agree? Okay. That is called one real root. Where it crosses the x-axis is a real number. Could be 2, could be square root of 2. It could be anything like that. It's going to be a real root. This one, you should be all familiar with this. This is a what? What degree? Parabola, which is degree what? 2. This parabola happens to cross the x-axis at how many points? 2. 2 points. This is crossing the y. So it has 2 real roots. 2 real roots, degree 2. This is what Miss Davis would refer to as discograph, right? This is a degree 3. Again, these have got to be familiar to y'all. If it's degree 3 and it crosses at 3 points, that means it has 3 real roots when it crosses the x-axis. Last but not least, this is going to be new for you if you haven't seen it before. This is a degree 4 polynomial. Degree 4s make m's and w's. That's what they make. Look for a w or look for an m. This is a w right here. And it's crossing 1, 2, 3, 4. 4 real roots. Now, obviously, they're not always going to cross the x-axis. But when they cross, and this is what I want you to write down. When the graph crosses the x-axis, it's a real root, meaning it's not imaginary. It is a real number. It's either 5 or -5 or 1/5, 2/3. Square root of 3, that's a real number. The only ones that are not real are what? What do they have next to them? That little letter, I. Okay? So these are all real numbers right now. And notice, degree 2, 2 roots. Degree 1, 1 root. Well, what if I made it look like this? And this is what you'll have to do for homework. It's not that hard. It's actually really, it's just visual right now. This is a degree what? What does this look like? Degree 3. Remember, this is that just disco graph? Okay. How many spots is it crossing the x-axis at? Do you all agree 1? So it has 1 real root. Take a wild guess on how many imaginaries it has now.
2.
Where are you getting that from?
There are 3 degrees, so there's 2 roots.
That's right. If you crossed at 1 spot, then you must have 2 imaginaries. Degree 3. This is a W. W's are degree 4. How many times is it crossing the x-axis? 2 times. Those are real numbers. Take a guess on how many imaginaries it then has. You got it. It's got to have 4, I put degree 4. It's got to have 4 roots. It's got to have, could have 2 real, 2 imaginary, could have 1 real, 3 imaginary. It's got to add up to 4. All right, this last one right here. This is a degree what? 2. This is a parabola. Is it crossing the x at all? So you would say it has 0 reals. Well, then how many imaginaries does it have? Does that make sense to y'all? This is really important that you get this. I know it seems, you're like, yeah, duh, I get this. I can count, Miss Aceta. But sadly enough, this is where people get tripped up, okay? So keep this in mind, and we're going to do 2 more examples, and I'm done. This is amazing, okay? Keep that in mind, these graphs. This is what the fundamental theorem says. We've got to have 1 root if we're over 1 degree. All right, so first example, and it's very, write a polynomial equation of least degree with roots 2 and 3i. Does the equation have even or odd degree? And how many times does it cross the x-axis? You could actually probably do part B before you do A right now. I'll show you why in a minute. This root is real or imaginary? Real. This root is?
Imaginary.
Okay, before we move on, I got to stop you because this is what the books do trick you all the time. If you have an I or an imaginary root, you always have 2. You have it and then its conjugate. Do you know what the conjugate of 3i would be? -3i. So you need to put right now -3i. Even though they didn't write it for you, anytime you have an imaginary root, you always have its conjugate. Actually, let's write that down. Always a conjugate for imaginary roots.
I thought there was 2 imaginaries.
Yeah.
Or like
Here.
2 doing the degrees too. There's only 2 roots.
But this isn't a degree 2. Yeah. This is not degree 2 right now. What is this degree what? 3. Because I have 1, 2, 3. So that's the trick of it all. You have to remember, if I have imaginaries, I must have 2 of them. There's always 2. There's a itself and then its conjugate. Okay. So I already know this is degree 3. I already know it's an odd degree. I already know that. It's an odd degree equation. 1, 2, 3 roots. Okay. Now, we can even answer this part. How many times does it cross the x-axis? How many times do y'all think? Why once? Because it only has 1 real. You got this. Good. 1 real root. So it crosses once. 1 real root means it crosses the x-axis 1 time. All right, now, how are we going to find this equation? We now have to write the equation. And you learned this last year. You might not have just put it together until now. The way that we do this is you're going to write, I mean, you can write f of x, but you're going to write, since there's 3 roots, you're going to put 3 parentheses. 3 roots. You're going to put x minus x minus x minus in all of them. Put x minus x minus x minus. If there were 4 roots, you'd write 4 parentheses, x minus x minus x minus. Are you with me on that one? 2, x minus x minus. All right, what do you think is going to go here, here, and here? Just take a wild guess. 2. What else? 3i and? Which really means that this becomes? Okay. Haven't we, like, didn't you, when you solve an equation, you factor it and then you set it equals 0 and this is what you're left with, right? And then you know how many answers there are, solutions. That's why this is where it comes from. So now you've actually written the polynomial as factors, but you haven't written it as a least degree, which means you haven't FOILed it out. You got to FOIL it out. That's all. So it's actually quite easy when you do conjugates. Conjugates, remember, you don't have to really FOIL. I've said to you before, you just FLA. Ah, it's so much fun. What's a negative 3i times a positive 3i? Negative 9 I squared. And what is I squared? Negative 1 times negative 9 is positive 9. So really, you need to right now FOIL this for me. X minus 2 times x squared plus 9. And if you think this is hard, don't. Just to give you a little picture in your head, because this is the whole point of what we're doing today. And it's hard to see. Mine's obviously color. But it goes down, it does that little dip, and then it comes up. And if you can see where it's crossing, it's actually crossing at the point 2. If I zoom in, actually I might even zoom 6. There it comes. There it goes. See how it crosses right there at 2? So it does this little dip down here, and then it crosses right there at 2. But it's a degree 3, so it has to have 3 roots. So, awesome. Easy breezy. Not hard. Please know how to do that. I promise you. I'm not lying. I'm not trying to like make you scared, but they do this in all the time in pre-calculus questions. They do this all the time, and they actually had it on NCEMPT last year. So they do it on that one too. All right, last question, example 3. Always checking on me. All right. So we are doing the opposite of what was just before. Before, you actually had to find the equation. They gave you the roots. Find the equation. Now I've given you the equation. Find the roots. Okay? So you are going to do something that starts with an F and ends with actor. You got it. You got it. Now, a lot of you, if you don't remember how to factor last year, this is what you have come to this class to be professionals at. When you see a trinomial, y'all, this is what you all like, but it's x to the 4th, but it's a trinomial. Trinomials can usually be written as 2 binomials, which means I could probably do this whole thing. What 2 numbers multiply to negative 36 but add to a negative 35? The middle. 36 and 1. So you put 36 here, 1 here. Obviously 36 would be negative, this would be positive. What do you put here and here? X to the what? Squared. Because x squared times x squared makes x to the 4th, doesn't it? Now, because there's a 9 in front, what do we do with that? This is what everybody always forgets. Divide the 9. Yes, if it reduces, reduce it. So 36 minus divided by 9 is 4. This one, though, you bottom up. So 9x squared plus 1 equals 0. Okay, now, can you factor any more? What does that factor into? Yep. But this one cannot, correct? That's done. If it was 9x squared minus 1, it could factor. All right, so now we know how many roots there are right now. What is this root right here? What's that root? Negative 2, which is real. What's this root right here? 2. Positive 2, which is also real. That means I'm going to cross the x-axis how many times? 2. This one, however, I've got to set this equal to 0, and I've got to solve for x. So let's see. I'm going to bring over 1. I'm going to divide by 9. And I'm going to take a square root. And when I take a square root, I put what precious little sign in front of it? Plus or minus. But yes, I am going to put an I. Why am I putting an I? Square root of a negative is an I. Okay, now everybody's like, I don't know how to take the square root of 1/9. Yes, you do. What's the square root of 1? What's the square root of 9? 3. What's the square root of 1/9? 1/3. Yeah, it's easy. So count it with me. 1, 2, 3, 4. 4 roots. 4 roots. Okay, now let me show you what this looks like. This is what you'll be doing tonight. You just have to sketch the graph. You don't have to make it completely accurate. So degree 4, for those who don't remember their end behavior, what's the end behavior of a degree 4? It looks like a degree what? 2. And what do degrees 2? They go either up, up, or down, down. Well, if it's a 9x to the 4th, it's going to go start up and go end up. And here's what's going to happen. It has to cross through -2 and it has to cross through +2. And it's going to make a W shape. So I'm going to go down, cross through -2. Am I going to go back up and cross through? No, I'm going to kind of go back up maybe just a little bit, come back down, and then cross through there. Well, actually, that y-intercept would be at 4. So it would be at -4. I'm sorry. I thought that was it would be at -4. So I should have gone down a little bit. But just to show you, 9x to the 4th minus 35x squared minus 4. Graph. Let's see if it'll graph it for me. Yeah, you can get the picture. Do you get the picture? Do you see the W there? And again, I don't need you to be accurate. I just need you to sketch because you now have to just be visual about what these look like. I know Mrs. said it, it's degree 4. I know it starts up, it ends up. I know it has crosses through the X twice and 2 of the times it's not going to. It's going to make a little bump right there. But that's what it is. You're so smart right now. You can look at an equation, know the answers, know how to graph it. Do you not feel brilliant?
I'm a genius.
You're geniuses. I'm so proud.